So this is going to be the second page of our conic section word problems. Now you'll notice with this page there's no pictures drawn with them, so you are going to need to draw some of your own. They don't have to be absolute perfection. Make sure though that they do cover what is being given in the problem. All right, so it says a bridge in the shape of a semi-ellipse. Remember, semi-ellipse just means half of an ellipse. Let's see, maximum, whoops, I don't know why I just hit that. Hold on a second, let me get rid of that. All right, maximum height of 120 feet and a width at its base of 80 feet. How high is the bridge? 25 feet from the center. Okay, so this particular ellipse has a maximum height that's 120, width is 80, so it's going to be a relatively narrow ellipse, but relatively tall. It looks nothing like an ellipse, but we're going to go with it. All right. Now, what I just did is I basically gave myself the XY axis. I'm going to call the center of the ellipse 0, 0. Now, it says it has a maximum height of 120 feet, so it's going to be 120. And the width at its base is 80 feet. But remember that 80 feet is going to be across the whole thing. To figure out our semi-minor axis, we actually want to chop that in half. And so that's going to be 40 feet along the x-axis. Now, order is not going to matter here with how you write the ellipse equation. So if you want to, you could put y squared first. I tend to put x squared first. And that's just, I'm going to do that and then pull this 40 as my this actually b value. So 40 squared is 1600 plus y squared over 120 squared is what would that be? 14,400 is equal to 1. So that's the equation that now would represent our ellipse. So that's a good thing. Now, the second thing we want to do is it says, how high is the bridge 25 feet from the center? So I'm going to go to the center. I'm going to go out 25 feet. So let's put it, I don't know, right about here. Let's say that's 25. And I want to know this height right here. So I know the x value is 25. It's the y value that I'm uncertain of. I don't know. So that's what we're going to solve for. So I'm going to replace x with 25. So 25 squared over 1600 plus y squared over 14, there we go, is equal to 1. All right, so 25 squared over 1600 is a not terribly pretty, there we go, slightly better fraction than it is a decimal. So it's 25 over 64. I just put it in my calculator, let the calculator do its wonderful calculator magic. Okay, I'm going to subtract 25 over 64 from both sides. That, I don't know what that was trying to be. There we go, 25 over 64. Let's see, I write too large, so y squared over 14,400 is equal to 1 minus my answer, so 39 over 64. I'm going to multiply both sides by 14,400, and this time I'm going to let it go ahead and be a decimal. All right, so times 14,400. Conveniently, that actually works out to be just the value of 8,775. There is no decimals or fractions here. I'm going to, let's see what I'm going to do. I'm going to pick that color, and I'm going to take the square root of both sides. So y is equal to plus or minus, let's see, square root 93.67, let's go 5. So that would tell me that in a true ellipse, if we actually had the full ellipse, we would have this, the positive 93.675, and we would have a negative 93.675 to deal with the symmetry of an ellipse. Obviously, with this bridge, it's a semi-ellipse, which means there's only half of it, so I'm not going to worry about the negative at all. So the height is 93.675 feet. Quick check, does our answer make sense? If the highest height is 120, yeah, this actually does make sense. It's an ellipse. It takes a while for the ellipse to really start losing height. So even though we're 25 units from the origin, yeah, it makes sense. What you want to be careful about is, obviously I keep doing that. My apologies, I keep opening up that goofy thing. But basically you want to be careful that if you know your highest height is 120, what you wouldn't want to tell me is that the height 25 feet from the center is 150 feet. That does not make any sense for an ellipse. Okay, so that's number 5. How about number 6 here? Okay. Highway overpass in the shape of a semi-ellipse is, all right, so we're dealing with a semi-ellipse again, is 200 feet wide. Okay, the highway running through the overpass is 120 feet wide. Find the height in feet of the overpass. Let's see what this says. At the edge of the highway, okay, if the overpass has a maximum height of 80 feet. So I want to translate this into a picture for myself. And so I know that our semi-ellipse here, hold on a second, I don't know what that was trying to be. Let's try that again. Okay, so semi-ellipse looks something like this, okay? And the semi-ellipse is 200 feet wide. There is a highway in here, right, that runs straight through the middle, and that highway has a width of 120 feet, okay? And we know that the maximum height of our overpass is 80 feet. So all of this together is going to create an equation for us. Now, I'm going to temporarily ignore the 120 because I want to create the equation of the ellipse. So first things first, I am going to recognize that basically where this highest point is my y-axis, right? This ground level, I'm going to make the x-axis. So that puts my center at the origin. So the whole semi-ellipse is 200 feet wide, which means half of it, right, from the center to one edge would be 100. So I'm going to use the 100 here, and I'm going to use the height of 80 here. So x squared over 100 squared, so that's 10,000. Yep, got enough zeros there. Plus y squared over, I think that's 6,400. It is. So 6,400 is equal to 1. So that's the equation of the ellipse. Now, what are we asked for? It says find the height of the overpass at the edge of the highway. So remember the highway in here is this 120 feet across, right? That 120 feet wide. And I want to know how tall the overpass is right there. Okay. So what you want to be careful about is x is not 120, right? The 120 spans both halves of the ellipse, it's both sides of it. So I actually want to take that 120 and chop it in half and just work with 60 feet on the left side or the right side. So then this point right here would be 60 feet on x, and I don't know how tall. Okay, that's what we're trying to figure out. So using our equation, I'm going to replace x with 60. So 60 squared over 10,000. Y squared over 6,400 is equal to 1. So let's see, 60 squared divided by 10,000 is going to be, and I'm just going to leave it as a decimal for this problem, 0.36 plus y squared over 6,400 equal to 1. Let's go ahead and subtract 0.36 from both sides. Mark that as subtraction. So let's see, y squared over 6,400 is equal to, let's see, what is that, 0.64. I'm going to multiply both sides by 6,400. So times 6,400, that does not look like a time sign, so let me mark that out. I'll use parentheses over there so I don't think it's another decimal for some reason. Times 6,400. So I'm going to get more space over here. So y squared is equal to 4,096. I am happily going to take the square root of both sides. So y is equal to plus or minus, let's see what that square root is. It is 64. All right, so this one actually worked out. Like, there's no decimals here. It's kind of nice. What I do want to check for is, does the negative answer make any sense? And the answer would be no, right? The negative answer would be underground somewhere. And maybe that applies in a different situation, but not for this one. Because we are talking about the maximum height, or the height, which is a positive value. So let's see, 64 feet. And since our overpass had a maximum height of 80 feet, it makes sense that we could have a height of 64. All right, last problem, I think. Yep, it is. All right, problem number 7. I think this whole page was semi-ellipses, which is okay. All right, so a semi-elliptical arch. Okay, so that is 10 feet wide and 4 feet high at its center. A 2-foot box is pushed through the door. How wide can the box be? Round to 3 decimal places. Okay, so semi-elliptical arch. Again, I'm not looking for perfection. All I want you to be able to do is understand that's sort of a semi-elliptical arch. Okay, we're going to count, let's see, we'll do pink. This is the ground, okay, and this is going to be the y-axis, so there's our xy axis. And if you can make the center be 0, 0, it just makes writing the equation so much easier. So let's go ahead and call the center 0, 0. We know that this whole thing is 10 feet wide. So we're going to chop that in half. So from the center to one edge is 5 on the x-axis. That's on the ground. And it is a total of 4 feet high at its center. So x squared over 25 is equal to y squared over, 16. Hold on a second. That's not equal to. That's supposed to be plus. I'll get it right eventually. Let me make sure I wrote that equation right. All right, x squared over 25 plus y squared over 16 equals 1. All right, there we go. Got it. Takes me a second, but I get it eventually. Now, it says that a box is 2 feet high, is pushed through the door. So we have a box here that is 2 feet high, and what we want to know is how wide that box could possibly be and still fit within the doorway. Okay, so a couple of things that we want to be careful about. We know that it's 2 feet high here, okay, for the box. What I don't know is how wide it can be. So I'm trying to figure out this point right here, because that point would be the x value that is the widest x value on one side that it could be. So I know x comma 2. So it's going to be x squared over 25 plus 2 squared over 16 is equal to 1. So x squared over 25 plus, what would that be, 4 over 16, so 1/4. Doing a quick double check. I have a calculator sitting next to me and I keep using it. I would highly encourage you to do the same. All right. I'm going to subtract 1/4 from both sides. So x squared over 25 is equal to 3/4. And then I'm going to multiply both sides by 25. Right, just taking my time, solving my equation here. Oops, hold on one second. Tried to make my calculator do the wrong thing. There we go. All right, so in decimal form, this is going to be x squared is equal to 18.75. Probably easier to work with the decimals than it is to work with the fractions for that part. I'm going to go ahead and take the square root of both sides. So x is equal to plus or minus, I have no idea. So 4.33. And there's some more stuff after that I'm just going to leave for right now. So if I look at my image, right, this tells me that this point right here is 4.33 units from the y-axis. So it could be 4.33 feet wide. on half of the box. Remember, this box is also going to go into the negative x values here. And so this point over here would be the positive 4.33. This point would be the negative 4.33. And I want to know the distance, the total distance between them. So one of the easy ways to do that is just take the answer that you just got. And in this case, we're going to double it. So we're going to say that this is 8.660, when you're supposed to get 3 decimal places, feet wide. All right, so that takes us through the last of the word problems for this sheet. I'm going to post a separate word problem practice sheet in Canvas. If you are looking for some more practice, use that as practice. You don't need to submit it to me. I will post a key along with it, but it's good practice so that you can actually get some practice doing these problems on your own. If you're looking at any of these problems and you are confused, please let me know. Either send me a message in Canvas or